In this video, we'll be learning about 7 basic electronics components that every beginner must know. We'll be covering the switch, relay, resistor, diode, capacitor, transformer, and transistor. So make sure to watch till the end. Also, don't forget to like this video and subscribe so that you can get notified whenever I post new videos. So let's start with the first component, which is the switch. A switch is basically a manually operated device that can turn a circuit on or off by making or breaking a connection. You can see this switch has 2 terminals on each side, and when I connect a voltage source in between these terminals, it doesn't flow any current. However, if I close the switch by moving this lever, then the connection between the 2 terminals gets established, and now the current flows through the circuit. Closing or opening of the circuit by a switch is called switching, and the point where the switch makes or breaks the connection is known as the switching point. Switches are further categorized into different types based on how they are operated. For example, this switch is an SPST switch, which stands for single pole, single throw. This means that when you operate the switch, a single contact is made or broken. There are other types of switches, like SPDT, which is a single-pole double-throw switch, or a 3PDT switch, which is a 3-pole double-throw switch. These switches have multiple contacts and different configurations depending on how they make and break connections. Next, we have the relay. A relay is an electrically operated switch, which uses an electromagnet to open or close one or more electrical contacts. Here, when we apply voltage to the coil of the relay, it gets energized, and an armature moves down, closing the switch contacts. When the current from the coil falls to 0, the spring brings the armature back up, opening the contacts. The contacts of a relay can either be normally open or normally closed. A normally open contact is one that opens when the relay is energized, while a normally closed contact closes when the relay is energized. Relays are used to control high-power circuits with low-power signals. For example, here we have a 12-volt 10-amp signal, which can be used to control a 230-volt 100-watt load. Third, we have a resistor. A resistor is a passive electronic component that opposes or resists the flow of electric current. In a circuit, resistors are represented by the letter R, followed by a number, and they have a color code that indicates their resistance value. The color bands of a resistor from left to right represent the resistor's resistance value, multiplier and tolerance respectively. Using the color code, we can calculate the resistance of the resistor. Let's take this resistor as an example. Its color code is brown, black, red, and gold. So using the resistor color code table, we get the resistance value as 10 ohms. The multiplier is 10 to the power of 2 or 100, and the tolerance is plus minus 5%. Therefore, the resistance of this resistor is 10 times 100 or 1000 ohms, or 1 kilo ohm, plus minus 5%. Now let's look at some of the different types of resistors. These are all carbon film resistors. They have a cylindrical body with metal end caps. Next, we have these resistors, which are known as metal film resistors. They have a rectangular body and are generally more accurate than carbon film resistors. These resistors have a wire-wound body and are commonly used for high-power applications. These are ceramic chip resistors. They have a rectangular body with 2 triangular-shaped ends. Chip resistors are commonly used in PCB designs due to their small size. These are special type of resistors known as variable resistors, or pots. They have a shaft that can be rotated to change the resistance value. These are commonly used in volume control circuits of amplifiers. The unit of resistance is the ohm, and the symbol is omega. The SI base unit is the volt, and the volt is equal to 1 ohm times 1 ampere. Power dissipated by a resistor is given by P equals to V squared by R, or I squared into R, where P is the power in watts, 5 is the voltage in volts, and I is the current in amperes, and R is the resistance in ohms. Now we'll be learning about the fourth component, which is the diode. A diode is a component that allows current to flow through it in only one direction. It has a positive terminal, called the anode, and a negative terminal, called the cathode. Let's connect a voltage source across a diode. When we connect the positive terminal of the battery to the diode is a node, and the negative terminal to its cathode, current flows through the diode. However, if we reverse the polarity of the voltage source, no current flows through the circuit. This property of the diode, that it allows current to pass only in one direction, is called the one-way property of the diode. Diodes are further classified into different types based on their characteristics and functionality. For example, we have these common diodes, also known as standard recovery diodes. They are general-purpose diodes, used for most applications. These are known as Zener diodes. They are used for voltage regulation. These diodes are known as LEDs, or light-emitting diodes. They are used as indicator lights or for display purposes. These are photodiodes. They convert light energy into electrical energy. These are also known as solar cells. Their main application is in solar panels. The unit of the diode is the ampere and the symbol is A. Now we'll be learning about the sixth component, which is the capacitor. A capacitor is a passive electronic component that stores electrical energy in an electric field. It consists of two conductive plates, separated by an insulator, known as the dielectric. Capacitors come in various shapes and sizes, but all of them have the same basic function of storing electrical energy. The unit of capacitance is the farad, and the symbol is F. 1 farad is equal to 1 coulomb per volt. Capacitors are further classified into different types based on their construction and working principle. For example, we have these capacitors, which are known as electrolytic capacitors. They have a cylindrical body with a positive and a negative terminal. Electrolytic capacitors store energy in an electric field between two conductive plates and the electrolyte. These capacitors are known as ceramic disc capacitors. They are small in size and are used for high-frequency applications. These capacitors are known as film capacitors. They use a dielectric film as the storage medium and are generally more accurate than ceramic capacitors. These capacitors are known as variable capacitors. They have a shaft that can be rotated to change the capacitance value and are used in tuning circuits of radios. The next component we'll be learning about is the transformer. A transformer is a passive electrical component that transfers electrical energy from one circuit to another through electromagnetic induction. It consists of two or more coils of wire wound on a common magnetic core. The primary winding is connected to the input voltage source, and the secondary winding is connected to the load. Transformers are used to either step up or step down the voltage of an AC circuit. Let's take this 10:1 ratio transformer as an example. If we connect a 100-volt AC source to the primary winding, the secondary winding will have 10 times the voltage, or 1000 volts. Similarly, if we connect a 1000-volt AC source to the primary winding, the secondary winding will have 10 times less voltage, or 100 volts. The ratio of the number of turns in the primary winding to the number of turns in the secondary winding determines the voltage transformation. In this example, the turns ratio of the transformer is 10:1. The ninth component we'll be learning about is the transistor. A transistor is a semiconductor device that can amplify or switch electronic signals and electrical power. It has 3 terminals, known as the collector, the base, and the emitter. Transistors are further classified into different types based on their construction and characteristics. For example, we have these transistors, which are known as BJTs, or bipolar junction transistors. They have a single arrow pointing from the emitter to the collector, indicating the direction of conventional current flow when the transistor is in active mode. These transistors are known as FETs, or field effect transistors. They have a gate terminal that controls the flow of current between the source and the drain. The symbol for an N-channel FET looks like a line with a small circle at the top and a larger circle at the bottom, while the symbol for a P-channel FET looks like a line with a small circle at the bottom and a larger circle at the top. Transistors can be used as amplifiers or switches, depending on the configuration and biasing. In an amplifier configuration, the transistor amplifies a small input signal to produce a larger output signal, while in a switch configuration, the transistor can turn on or off a circuit based on the input signal. The unit of transistor is not defined, and there is no particular symbol for it. I hope you found this video helpful. If you did, please hit the like button and share this video with your friends. Also, don't forget to subscribe so that you can get notified whenever I post new videos. Thanks for watching.